right, guys, in this block, we are going to go through some simulations, surveys, and experiments. So this was kind of the unit that got a little bit cut short. It is pretty self-explanatory, but I will go through this just in case. And remember, don't hesitate to reach out if you have questions. So studies have indicated that there's a strong negative correlation between the number of times per week that you brush your teeth and the number of cavities that you get each year. Which of the following can be concluded from this information? So I went ahead and drew my little graph to kind of get an idea. So it says not brushing your teeth causes you to get cavities. Remember, we can't make a claim. We can't claim something that feels like super like if this, then this. We can say words like likely or good. So I'm going to put a maybe here. There's statistically significant evidence that brushing your teeth prevents cavities. I don't know what these studies were. I'm going to put a maybe here and come back. But I know for sure to get rid of A, which is polarizing. It looks like the lower the brush, so if I only brush my teeth a few times, I have a high amount of cavities. So I'm going to go with B, because according to this information, that's what I can conclude. So remember, we can't make huge claims here because I don't know how this study was done. But I can say people who don't brush their teeth are more likely to have cavities than people that do based on this information. This is on number 47. Just skip this. This is another case of the formatting got super jacked up here. Number 48, a report on a new brand of headache medicine, Probenal, is published saying, after extensive research, there is statistically significant evidence that Probenal reduces the likelihood of getting a migraine headache. Explain what that means to someone who knows nothing about statistics. So really what you're saying, if there's statistical evidence, then we're saying that this is there is enough to show that it's not random, right? So we can say that enough studies and enough experiments have been done to conclude that the relationship between Probenal and the reduction of migraines is not coincidence, so that we can conclude that it likely helps with migraine reduction. Almost always when we're looking at, I just read 49 and I saw water drops, and I was like, most of the time when we're talking about water or something like that, that is going to be that placebo or that control variable. So let's read this through. An eye doctor believes that he has invented a new drop that improves eyesight. He randomly selects 200 people, has them read an eye chart, administers the drop, and then has them read a similar chart noting improvement. Despite telling everyone they'll be receiving new drops, he only gives 100 of the subjects actual, and the other half is given water drops. So the purpose of the water drop is to kind of it's to prove that that it's not a placebo effect. And remember, a placebo is kind of like a fake out. So he needs to administer both to prove that it's actually causing, it's actually helping read the chart. And not oh, I think that I'm receiving these eye drops, so I automatically have better vision. The factor in this experiment is the eye drops, and the treatments are essentially you have a factor, and from that factor you should stem into 2 treatments is usually best. So the factor in this is going to be eye drops, and the treatments are actual versus the water drops. And this is just blind. Remember, double blind would mean that the administrator also doesn't know. So it's just blind because you only have one group that doesn't know what's happening, and those are the customers or the patients. For it to be double blind, so it's just blind. For it to be double blind, the doctor would not have to know as well. Let's look at this guy right here. The principal wants to know if the BHS student would like the library to stay open longer during the day. She gathers a random sample of 100 students from each grade level. What is the population? What's the parameter? And then which of these most accurately describes this sample? So because we're doing a random sample, we know it's not census. Remember, census is everyone. I'm going to kind of work my way up. She Since we are grabbing people from each grade level, this is going to be a stratified random sample. Think about like strata in the earth as kind of like those layers. So we are being random, but we're not just like randomly taking 400 people in the whole school. We're making sure that that randomness is equally distributed. The population is like, who is everyone? So the population is going to be the BHS, student body. The parameter is like of interest is like, what are we actually looking? Like, what is my constraint? And that's that question, does the library need to be open longer? So library, later. Guys, moving on to this last little bit. Remember, confounding variable is a variable that like actually impacts the situation. So, it is like associated with levels in another factor. For example, like feeding, I think the example in the thing is like feeding cats and dogs the same new food and comparing health benefits will not be able to tell any difference in the animal's health due to like the food or to the difference in how the species responded. So essentially, like what we're saying is like a confounding variable means that like this experiment wasn't done in such a way where there's like only one thing that's changing. It's like you could say, well, there could be other things that are impacting or like driving your results in a way that's not going to be super clear cut. Difference between stratified and cluster. Remember stratified, think about strata on the earth, you're dividing by certain characteristics. So for example, in this previous, it was like everyone in 9th grade is one strata, 10th, 11th, 12th. Where cluster, you're like grabbing someone in one area and you're grouping people around them. And all clusters are going to be similar to each other and to the whole population. So a good cluster would be, if we talked about neighborhoods when we kind of talked about cluster sampling, a good cluster would be a neighborhood that's like, you have a high income neighborhood, you have a low income neighborhood, right? For the population of Denver, a good cluster would be somewhere where there's like a pretty good mix and represents Denver as a whole. Whereas like the stratified would be like, let's look at different races or like completely separate neighborhoods or factors. Remember that what blocking does is blocking isolates the variability between differences of blocks. So for example, I think when we looked at that, like the window problem, right? You would want to block, like if you had north, south, east, west, you would want your blocks to isolate that side because like the whole idea is that we're trying to show like let's isolate the variability due to the difference of the blocks so that we can actually see the difference caused by treatments very clearly. So if we had two different types of windows, we would want to compare window type A and window type B, both in that north block. We'd want to compare window type A and B, both in that east block, south block, and west block. And remember, the purpose of randomization is truly just that we don't want to have bias, and it wants us to kind of like equalize the effects and like lower the impact of our like personal bias. And remember, what bias is like whether it's accidental or on purpose, you're favoring a certain outcome.